or having the hypothetical in place, and we have utility for no. We have two states of utility, and we have some sort of function underneath it. And within this function underneath it, we have a ratio of prices to these are the parameters that we can estimate, and this is the price that we can propose. So each person consuming would have some place where they would be on a demand curve, and they would be making a discrete choice of whether the utility would be higher or not based on this price ratio. This random utility model is also called a referendum voting model, and when we put an error term in there, we can say that each person is going to have different amounts that their error term is going to say whether they want environmental good or not. And then we can have a statistical model to say whether each person's individual motivation to have an environmental good would mean whether they would be on the yes or no, whether they would vote for it or not, based on these parameters we can estimate about the price. So when we do statistics in economics, we call it econometrics. So we have an econometric model that's based on the environmental sort of interior choices of each person. Here's an error term. And we have two states of an environmental good and a parameter that we estimated about it, a price that we will put out there on the schedule. So for each price, some people will vote for it and some people won't. And we can use our econometric model to estimate the alpha and the beta to sort of, one's a shifter up and down, one's a slope responding to the price. And so we can get our econometric model to fit this sort of discrete jumping demand curve to our data. So the second area in stated preference models can be motivated by this question of discrete choices, and this is where we're going to try and elicit people's valuation, elicit people's demand curves by giving them sets of choices. I think in the book it's called conjoint analysis. Sometimes they're called choice experiments. Sometimes they're called discrete choice experiments. But what you want to do here is you're saying, look, it's not just a 0-1 thing about protecting Prince William Sound. It's not just more wolves, less wolves. Sometimes environmental amenities will have multiple traits, and our model would be better if we gave people multiple choices. And people are trading off a few different things. They're not trading off one thing. So let's try and have a technique where we can have people trade off a couple of different traits. The more traits you add, the more complicated it gets very, very, very quickly. But let's just do it with a few choices. And we'll make little subsets. So wolves in Yellowstone, we have the number of wolves, the quality of the water in the stream, which is I tried to motivate was the outcome of that, the number of elk, and then a price. So we can have a couple of different attributes and a price. And we're going to vary those prices. What would people pay for different sets of attributes? And when you're doing the survey with somebody, instead of at the end saying, would you vote for this, yes or no, you would get people to rank things. Would you prefer A to B? Would you prefer B to C? And by doing that, underneath that, if you have a set of prices, you also are implicitly getting a demand curve. So all of these are ways to make a demand curve. So our first example is Glen Canyon Dam in Arizona. Anybody know where this is? All right, the map's on the next page. But it's a big history of environmental controversy. The environmentalists fought against it. The Sierra Club fought against it. It was a question of how tall it was going to be and how far the lake that was going to be behind it was going to back up. But importantly, that's back in the 50s when the Bureau of Land Management was building ginormous concrete things. But importantly in dams, there's flood control, there's using the water for irrigation and for cities, and there's making electricity. So there's a couple of different attributes there. This dam makes a lot of electricity. But importantly, the sediment gets held back. So silt that would naturally be washing down the Colorado River gets caught behind the dam. And the water that comes through that spillway there should be full of sediment. The fish, there's this local fish, the chub, and they depend on these sandy, silty banks of the river down below for their habitat. And without sand and silt and sandbars, there's no habitat, and this population of fish has been in drastic decline. So what they have tried to do in just the last 15 years is they try to open the dam really big at certain times of year when they have extra water and shoot some sediment out of it. You can see up there's two jets coming out. There's one that's the electricity producing area, and then there's another one that's like a spillway where they can open that up and try and shoot some sand out. And they've been trying to do that. Unclear whether it's successful or not. But that's jumping ahead. All right, here's our map. Two huge dams in Arizona, the Glen Canyon Dam and the Hoover Dam. Two biggest man-made lakes in the United States are Lake Mead and Lake Powell. So Glen Canyon Dam is what makes Lake Powell. You have a question? I don't know. Probably, I don't know. Couldn't tell you. What's important is that these states have what's called the Colorado River Compact. And that they have a multi-state division of who's going to get the water from the Colorado River. This upper dam is to divide half of the water of the Colorado River, which at the time they estimated was 7.5 million acre-feet, between Colorado, New Mexico, and Utah. And then there's this lower dam, which is the lower Colorado Compact, dividing it between Arizona, Nevada, and California. And then a little bit of it sometimes is allowed to go to Mexico, where it's raised too. But they have a big city down there, so they would love more. And they have a lot of agriculture as well. At the time that it happened, agriculture wasn't as developed in Arizona, and so California was going to take all the water, which they did. So Arizona had a hard time until they were willing to take as much water as they could. The other thing that happened is this 15 million acre-feet that these states are dividing up was from some estimate far in the past, in the 30s or the 20s. And so how much water that comes down the Colorado River is something between 2 and 20 million acre-feet. And they don't have a way, they've had to readjust things as the amount of water varies a lot. A lot of the water goes to California, as you know, and Imperial Valley, Los Angeles are getting Colorado River water. All right, so here's before and after pictures of what the sandbars might have looked like. So this is before there was a dam. There's a big sandy beach here. These people have pulled up on the beach. This is the same beach, the same setting, 4 years after the dam, and it's just rocks. So you can see like some sort of fish population. Fish habitat has been changed, let's say. A lot of sediment's trapped inside. I don't know if you can see the color on this picture, but the river is green. The color of the river is green. It's supposed to be sort of a silty, chocolatey brown. So the quality of the water is completely different. So they were trying to estimate and do an environmental impact statement on the relicensing to justify this new program of letting some of the water out in these surges to do some mitigation. I just want to go back one thing that I may have not pointed out. So between the two of them is the Grand Canyon, the national park of the Grand Canyon and the natural part of the Grand Canyon. So where people are rafting and recreating and visiting. So the health of what we do is something that the health of this river is something that people actually perceive and consume and stuff. So there were a variety of, this is the choice experiment, there's a variety of costs proposed. A range of costs, a range of populations of fish, less fish, same amount of fish, more fish, less sediment, same amount of sediment, more sediment. So there's a range of different choices and attributes here. If you did the full factorial, every possible combination, you would get a huge number. You get 150 different choices. People can't cognitively deal with 150 choices. You have to make some subset of them that people can actually compare, people can actually cognitively make choices about. So here's just a sample of what one of these would look like. Option A, option B. One costs $60, one costs $80. The $80 one has some lesser sediment and some twice as many fish. And then you ask people to vote on these cards. And you have people vote on a series of cards after motivating things. You can take these and put everybody's votes on all the different cards back to estimate a demand function. And then you can do a simulation of this demand curve. This is whether people would vote for something. And this is reflecting back to the card before. And this simulation of changing here, changing the number of fish in the river based on different prices, is going to give you a consumer surplus and a willingness to pay. So some of the questions are how we sum this up. So are we going to say anybody who visits the Grand Canyon? Are we going to say anybody in Arizona? Are we going to say all Americans? So these surveys can come up with numerical estimates of how much people are willing to pay for some attributes. But then there's a whole question about how we get that into the, what's the total value? This is an individual person voting, but how do we get that into a total value for everyone? Okay, another example. Anybody a mountain biker here? No mountain bikers? We got one mountain biker. All right. So I like this survey. I want to present it. I'm not a big mountain biker, but I have enjoyed it. It's great. We live in a great place for it. This is a survey that said, would people be willing to pay for single track? Would people be willing to pay that little dollar amount for riding on single track? They went here not to average people, but they went to an area of people riding bikes with a survey. And then they asked a whole bunch of different characteristics: male, female, what kind of rider are you? Are you an avid rider, a road rider? Like they're trying to get subsets of population. How into riding are you? Have you ever raced? Have you ever been on a team? How many days a week do you race? Do you do it to train? Do you do it just to get out? Do you have a suspension bike? Do you have clipless pedals? Some things like this would sort of get at are you serious or not? How much did you pay? How long have you had your bike? Some people have lots of bikes. But then they had a set of choices, which is how long the trail is, a short, medium, or long trail, and what percent of it's single track. Do you want to ride not at all on single track, half the time on single track, or completely on single track? Do you want it to be a mountain, short, long? Do you want to just go up one, come down, or do you want to constantly go up and down? And then what if there was a fee that you had to pay to ride your bike there? And another big one that comes up is, are there going to be other people on the trail? Here in the Bay Area, almost all the single track is closed. We have a couple parks with single track. But Mount Tam, for example, one of the birthplaces of mountain biking, you can't ride single track on Mount Tam because the hikers have said, look, it's too dangerous to have bikes coming down. UC Berkeley, Tilden, all the areas in the East Bay parks, no single track available for mountain bike. Fire roads only. So anyways, you have a bunch of attributes. You make a set of cards. They went to a bike show in Portland, Oregon, asked 300 people a survey. What do you think happened? Hello? It was me gesticulating wildly. All right, hopefully I'm still on. I jiggled it. Here's a picture for those of you who have never been mountain biking. Double track, or what we call a fire road, is basically like a Jeep road. There's lots of these throughout the western US, all over the place. Single track on the other side, that's a lot more fun. You're basically like on a hiking path. It's more exciting. There's like stuff to go over. It's cooler. So people want single track. Interestingly, in the Bay Area, there's now one or two places. There's a place in Marin County where I was saying Mount Tam's all closed off. There's a place in Marin County, a Boy Scout camp called Tamarancho, where you can pay. You can join this club and you can go and ride single track. Like basically, you pay some small fee, but this is people paying for single track. It's happening. Other places that are sort of more rural, there is tension between the people that were riding their horses there and then here the mountain bikers come. It can get tense in certain places. But so basically, back to the study, they're coming up with a per ride, how many times, so this is what you do it over per person, but they came up with a per bike ride compensating variation measure. And they did a few different attributes, one of which was introducing a fee to ride your bike there. One of which was keeping hikers and horses off some of the trails. One of them was no single track. And the other one was building more single track and charging people money. So they're having some certain outcomes of their choice sets, and they're seeing what the welfare measure that we talked about, what's the consumer surplus of these different moves. And this is sort of a complicated table. I'm just going to say people are doing a lot of different statistical analysis. There's a lot of little tables out there. I'll just go for the last one, proposal 4. An access fee to get more single track. And what's interesting here is everyone but the hardcore mountain biker thought that would give them negative consumer surplus, but the hardcore mountain biker has a positive value. They're getting a consumer surplus from this single track that nobody else is going to be on. They're going to be able to pay to go on this awesome single track. So different statistical models getting different measures. So stated preference. There are a lot of ethical issues. There's methodological issues. But people have some resistance to these stated preference models sometimes. One of the main ones is look, nature has a value. Creation has a value. It's not about putting a dollar number on everything. If we try and ask people for just how much would you be willing to pay on a tax to give me nature, that's going to underestimate this true value of it. One way to think about that is you're asking, you're sort of framing and narrowing the choices so that there's trade-offs, there's substitutions. You're going to say you could pay for this or pay for that. But some people would say, the value to me is infinity. I don't have a large income, but I really wish that there was pristine ecosystems. I really wish that there was wolves in Yellowstone. It's worth more to me than any amount of contribution that I can make. I wish that there was whales out there in the ocean going by. I'm not going to do anything with them. I'm just going to occasionally see a whale going by. The big whales, humpback whales, maybe you can see them. Blue whales, very hard to ever see them. People care that they're there. And another critique is that, look, the right for the pristine environment, the right for the wolves or the whales to exist, it's not something that's a consumer good. It's just an innate right. Doesn't nature have some rights to exist by itself? So what environmental economics says as their justification is the value of this good is between 0 and infinity. And what environmental economics does is try and take a stab and narrow the range between 0 and infinity, which is a pretty low threshold to say, but justifying what we're doing. A second set of critiques of stated preference techniques are that there's a hypothetical bias. You're asking people a hypothetical question. When you do that cognitively, you're moving away from actual economic choices. In contingent valuation, you don't really have to pay. I'm just asking you hypothetically, would you pay? But I'm not actually asking you to take money out of your wallet and give it. So that's a different way that people behave when they're asked hypothetically, how would you do? But there have been studies later that have shown that people don't necessarily overstate. If the study's well written and the choices are sort of compared to other choices, people don't actually inflate their numbers that much. And we do have these reality checks. We do have this way, people pay for hunting license, fishing license, wilderness access fees. People have expenditures on what it takes to get them into wilderness. People make trips to see biodiversity. So we do have some sort of reality checks that people do make choices about biodiversity, for example. Finally, there's some critiques about how do you do this thing about scope. So people ask a survey, this lake is polluted. Would you be willing to pay $20 to clean up this lake? People would say yes, or 51% of the people would say yes. But would somebody pay $20,000 to clean up 1,000 lakes? And there's plenty of lakes that might need to be cleaned up. This is from another study. They found that people had a willingness to pay $26 to clean up the water that was nearby their community, but $68 to clean up all the water in the United States. So this thing of people can have a willingness to pay for something that's near them, but how do you multiply that out to things that are more and more remote? So this difference, $26 for one local lake versus $68 for a global cleanup, is not necessarily consistent in economics, but your willingness to pay is going to be higher for something that you know about, that's local, that resounds with you. It's going to sort of click something for you that would be higher. All right, I want to move to the Prince William Sound survey here to give you an example. If you guys have a phone, you can pull this up for the survey at the end. So let me switch really quick. Or you can write down the URL and go there on your device when you get a chance. Let's see. All right, I'll give you the URL at the end again because I want you guys to vote, and then next time we come back, we can look at our own data. All right, so somebody comes to your door, you live in Ohio, you're not born yet, but maybe you're rolling around on the carpet on the floor, and you're learning to crawl. But anyways, 1994 in Ohio, somebody comes to a randomly selected set of households telling you about the Exxon Valdez oil spill. I can't do the whole thing because I'm going to abbreviate it a little bit, but we are faced with many problems in this country, none of which can be solved easily or inexpensively. Here's a few of these problems. Tell me whether you think we should spend more, less money than we're spending now, giving aid to poor people, making sure we have enough energy, fighting crime, making highways safer. The other thing we can do is protect the environment or clean up after environmental accidents. How important to you are these different following issues? These are areas where our government can spend money: expanding drug treatment, reducing air pollution, providing houses for the homeless, reducing taxes, putting a space station in orbit around the Earth, or protecting coastal areas from oil spills. Is this extremely important, very important, not too important? Over the past 20 years, the government has set aside a large amount of land as wilderness. Do you think we should protect areas as land as wilderness? Blah, blah, blah. A spill occurred in the March of 1989 when the Exxon Valdez oil tanker ran aground on a reef in Prince William Sound, Alaska. Part of its cargo, 11 million gallons of crude oil, spilled into the water. Do you remember hearing anything about this? What do you know about this? I'd like to describe a plan to protect this part of Alaska from the effects of another oil spill. First, I'm going to give you some background. Here's a map of the state of Alaska. In the upper right corner is a smaller map showing Alaska compared to the rest of the United States. Alaska is very large. In 1967, a large oil field was discovered in Prudhoe Bay on the north slope of Alaska, up at the top. The Trans-Alaskan Pipeline opens to take the crude oil from Prudhoe Bay down to Valdez, a port on Prince William Sound. The area in the blue is Prince William Sound. In Valdez, the oil is pumped into tankers which sail down to ports in the lower part of the United States. The oil is refined into products including heating oil, gasoline, and fuel for electric power plants. 1/4 of the oil produced in the U.S. comes from Alaska. Have you ever been to Alaska? Do you know anybody who's been to Alaska? How many times have you been there? This map shows Prince William Sound. It's an enlargement. The sound is a body of salt water over 100 square miles. As you can see, many islands and inlets, so its coastline is several hundred miles long. From Valdez, this is the route that tankers use to the Gulf of Alaska of 75 miles. They go out to the open sea through this channel. This photo shows Valdez from the air. Oh, I don't have this one. This is the area, and this is a view of the part of the sound. It's ringed by high mountains. There's glaciers that come off these high mountains and break up and produce small icebergs. Let's see here. There's the city of Valdez and the Valdez Narrows. And icebergs from the glacier come out, and they fill up the sound. Much of this land has been set aside as national forests and state parks. People use the area for fishing, boating, camping, and other recreation. This part of Alaska is also home to a great deal of wildlife. I'm getting behind. A number of different types of birds, sea ducks, bald eagles, grebes, and murres live in the area. The next photo shows seagulls and cormorants on a nesting site on a cliff. And this one shows a group of murres. In addition to birds, animals such as sea otters and seals, what are you guys going to say? Live in the area. Here's a sea otter floating on the water. The next photo shows a tanker sailing through the sound. 2 tankers a day, or over 700 tankers a year, make this journey. Many are super tankers as long as 3 football fields. The super tanker Exxon Valdez is carrying 53 million gallons of Alaskan crude oil when it ran aground on an underwater reef. The 11 million gallons of oil that spilled made it the largest oil tanker spill to occur in U.S. waters. Winds and tides spread the oil over a large part of Prince William Sound, part of the Alaskan coastline outside the sound. There's questions. Did you hear about it? Here's a map of how the shore was affected. The currents floated the oil from Prince William Sound. This color shows where the oil spread. The farthest point it reached was, I don't have my thing here, it was up here. 1,000 miles of shoreline inside and outside the sound were affected in this way. Because of the wind and currents, the shore was heavily oiled, some lightly oiled, some not affected at all, some outside the sound. This map shows how the oil spread in Prince William Sound. The red color